Hi everyone. Here's just a little screencast about a couple of the issues that people are still having with Unit 2A and 2B stuff. Okay, so I can't go over explicitly the questions because not everybody's taken the 2A and 2B quiz, but what I can do is I can go over the concepts. So it seems like people are still having some issues with El Nino and thermohaline circulation. So I'm going to go ahead and I'm going to kind of tackle those together. So if you have the Earth here, doesn't matter what color it is, and then here's your equator. I'm going to draw it just a little bit higher so that we can kind of focus on the southern hemisphere, that being South America. It is. My drawing game is completely off today. I'm sorry. Okay. But what we have here is if you took a cross section of the ocean and this were let's say the surface of the ocean here, and this is the bottom of the ocean here. This is the equator, and this is, let's just go with North Pole, okay? So at the equator, you're gonna have really hot, warm water, okay? It's gonna rise up to the surface as indicated by a red because warm water floats to the top. And then at the North Pole, what you're going to have is you're going to have really, 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 really cold, super salty water. And what's going to happen is that's going to sink. Okay. So if we're looking at these words, you're talking about thermo, which is your temperature, and your haline is your salts or your salinity. Okay. So convection currents, like when we were talking about the air circulation cells, what you have is you have the warm air rising up at the equator, and then it moves across and it sinks down at 30 degrees north and south of the equator. So here it's wet, and here it's pretty dry. Okay. Here it's also really warm, and that's why all of this water is evaporating. Okay. Here you have your warm air or your warm current, and it's rising up to the top. You have your cold water, and it's going down. So it still is, it's a convection current. This is a convection current because it cycles around and around and around because of temperature differences. Here, there's something very, very similar. Okay. Because your cold water is sinking, this right here starts all of the thermohaline circulation. So you have super cold, salty, there we go, water, and it sinks. It hits the bottom, and it's got to go somewhere. So it travels across because at the same point in time, what you have is close to the equator. You have this warm water now that this area now is lacking because all of this is sinking. So you need something to replace it. So what happens here is this sinks, this rises, this moves over, and that starts your whole thermohaline circulation, otherwise known as the Great Ocean Conveyor Belt. The Great Ocean Conveyor Belt is this, it goes back and forth. The reason why it's going around and around is because of thermohaline circulation, okay, because of the temperature and the salinity. All right, so that brings us over here. You have the southern hemisphere, excuse me, and we're going to go ahead and draw in another, this is our 30 degrees, and here's our 0 degrees at the equator. So what you have here is you have warm water being pushed all the way over here because you also have these prevailing winds that go this way here and this way here. Sorry, I didn't draw in the polar, but they would go that way, but nobody really cares about them. Sorry, poles. And what you end up getting over here is you get this warm, hot water over here, and these are our normal conditions. And then what you get is you get this cold, super salty water being upwelled off the coast of Peru here. Well, Peru is like right here. Okay. And then the Galapagos Islands right here are completely surrounded with cold water. Okay. During a La Nina year, these winds push this water, even this batch of like really hot, warm water, they push it all the way over. It almost falls off the flat earth. And then over here, what you get is during La Nina, okay, you get this cold water that extends out even further. Okay, so now bringing it back to El Nino years, what happens is these winds over here, They're like, meh, I'm good. I'm not going to blow anymore. And so what you end up getting is this warm surface water that was all blown over here. It starts to migrate back. Okay. And so now it's all along during an El Nino. Okay. And what you end up getting here is this upwelling. It still happens, but it's offshore and it's really low. So a lot of this cuts out over here. Okay. And in Peru, instead of having this cool, dry climate now during an El Nino, because it's surrounded by this warmer water, you get more wet conditions and warmer conditions. Okay. So bringing this back as well, let's take a look at seasons. Okay. It seems like people were having issues with that. So if we have our equator, well, we're going to draw sun. See if I can move this over. Maybe not. Oh, there we go. All right, so this big yellow thing over here is the sun. Obviously, it's way bigger than Earth, but for our purposes, this is what's going to happen. Okay, so here, oh my gosh, this is terrible, but bear with me, here and here. So in our 0 degrees Celsius, our equator, you get more concentrated sunlight. And then over here in your north and your southern hemispheres, the further away you are from the equator, you get less concentrated sunlight. Right? Now, if we know that the Earth's tilt isn't, it's not actually even. So the Earth tilts, and this is, I'm making it really dramatic. Okay, so here it is summer. Here it is winter. We know what winter is in our northern hemisphere. So at the winter solstice, okay, here it's completely dark. Okay, here, right there, it is completely light for like 2 weeks. I could be completely wrong with this, but I know they do have 24 hours of light and dark, and it takes about 2 weeks to get any decent amount of light or to get any decent amount of dark. Okay, so Earth's seasons are because of the tilt of the Earth. Okay, so that concludes this little review screencast for your test, either tomorrow or on Wednesday, depending on when you see me next.